So, good morning, or good afternoon, or good evening to everyone. And I am Joseph Fernandez, and I'm here to present my image recognition about the dogs and the cat. So, the project demonstrates the use of image recognition, a process where a computer identifies and classifies objects in an image. The backbone of the system is a convolutional neural network, or we call it CNN, a specialized deep learning model designed for image processing. CNN work by automatically leaning important visual patterns like edges, shapes, and textures throughout a series of mathematical operations. This project involves training a CNN to recognize image of different classes, example, animals, just like what we code here. Using labeled datasets stored in a directory, the process includes pre-processing images, training the model, evaluating its performance, and saving it for future use. Application of image recognition includes face detection, self-driving cars, and medical imaging. So, the importing libraries, as you see, we have 5 imports, and the first is, what do you call that? OS. So OS is used for managing directories and accessing image files here, and that's what we see here is enabling it, the one DNA. So the next is import CV2. Part of OpenCV, a library for reading and pre-processing images. Test is resizing or normalizing pixel values. Here is the CV2, and it works. That is what it works in the pixel values. Sorry. NumPy, we called it as NP. NumPy handles numerical operations like storing images as arrays for processing. Next is Keras. Yes, it's Keras. And last is TensorFlow. TensorFlow is the important here because it provides tools to design, train, and test neural networks, including CNNs. These libraries simplify the complex processes involved in image recognition. For example, without OpenCV, resizing and reading images would require custom implementations. TensorFlow is crucial because it includes pre-built functions for defining and training the deep learning models. So here are the parameters. So defining it, I will define its parameters. Image size. The image size is used for resizing all images to 128 by 128 pixels for uniformity. So this is, we put a value here for the image size. So the next is image channels. Refers to three color channels: red, green, blue in RGB images. Next is model name. So the model name, as we see, is used for the Keras with its name name in animals _CNN. So the test image is used for what do you call that? Testing the the images here, like here. If you want to test the cat 146, then the result in our program, the result will be goes like this. Yeah, and plain dr, yeah, the directory is train. So define classes, all classes, yeah. This is used for the function to define classes dynamically from training directory, and load the train model. Our code is if not OS path exist, yeah, if not existing, so raise the file not found error again, and writing the model name not found, and check the file path. So printf, printing the loading model, then it will goes to the model name. So in next is get the class labels. This is in the test page. Get the class labels. So here's our code. All classes equals to define classes in the train directory. As we see, we train directory. If not all classes, so again raise value error. No classes found in directory. Train dir. Ensure it contains a subdirect print subdirect. So print classes all class. So here's the pre-process section, the test image. So if not, yes, again, if not exist, raise again the file not found error. So test image. So here the tested image and are not found, and check the file path. If you test the image and it goes error, so this is our warning, or what we call it, it will show that you have an error image. So to perform prediction, so here's our code in prediction. So we write predictions equals to model that predict the test image. Next is predicted class index. Yes, np.argmax. It is the index of highest probability of the prediction. So predicted class, all classes, predicted class image index, and the confidence equals to predictions. Value 0, so predicted class index times to 100. So here's the last in our test, is display the result. So print predicted class, and yeah, the predicted class, the confidence, and the probabilities here. So it will show the result. Here's the result. Here's the solution for them, yeah, for the class probabilities. So in our train code, as we see, I've already what we called it, I've already explained this, yeah, the sequential, yes, this, and our function in our train part is, yes, here's the function to read all classes in train folder. All classes, yes, we put here for folders in os.listdr, the train dr directory, all classes append folder, return. And here are also our code for the function to define labels as one hot coded arrays. And yes, here it is. The def crate train data. Here it also. These are our codes, and also provided by our teacher, and we've just edited some of the codes so that we could get the high accuracy in testing the the what we call it, the dogs and cats in their image recognition. Yes, the epoch. So we know that it's too no not too long na if we wait for it. I've just recently run the code, so here's the epoch. Yes, the value accuracy. It's over 50. Then it's too long, so that is why I just run it uh, recently, so that I could explain this more in a short time. So we'll go to the test by, as we have seen, cat 146. Huh? We will test it. We will run the code. Yes, we will wait for it. Sorry for the long wait because of my computer is so slow now and it's so old. So our what do we call that? Our program predicted that the cat is 91.47%. Predicted class is cat. So as you see, our code, our program predicted that it is a cat. So what if we change it for 149? Excuse me. Yes, as you see, it predicted also the class excuse me, cat, and it is 91.47% confidence over it. So here's the probability, and as you see, yes, our code is running well. Yeah, you can use our code this in predicting images with image recognition. That's all, Miss Verdun. Sorry for the late pass because at first I didn't know how to explain it. I can't understand it, but as soon as I study the codes, and even and some of this, I am started to get understand about this. So sorry, ma'am, for a late pass because yes, my time is so full. And again, I'm Joseph LEMUEL Fernandez, BSIT 3. I am solo presenting my project, and thank you.